UL 60950, which focuses on information technology equipment safety, doesn't explicitly mandate remote power disconnects for remote tele systems, often referred to as RTS. However, it does require accessible main power switches or circuit breakers as well as overload and short circuit protection. A customer might argue that remote power disconnects enhance safety by enabling rapid and straightforward power isolation during emergencies. They may also contend that RTS are sometimes located in potentially hazardous environments, making access to the primary power switch challenging. The company's viewpoint is strengthened by the UL listing, which implies that the equipment adheres to safety standards even without a remote power disconnect. The company's counter-arguments could be firstly, that RTS are intended to be installed by certified electricians capable of evaluating the need for supplementary safety precautions. Secondly, the main power switches or circuit breakers included with the RTS fulfill UL requirements for secure power isolation. And thirdly, the addition of remote power disconnects post-factory installation might invalidate the UL listing. To settle this dispute, consider the following steps. Firstly, review the installation instructions to see if there is any guidance regarding remote power disconnects. Secondly, consult with a licensed electrician to conduct an on-site assessment and determine whether a remote power disconnect is either necessary or advisable. Thirdly, engage in negotiations with the customer, elucidating the company's stance based on the UL listing and propose collaboration to achieve a mutually agreeable resolution that satisfies both safety and compliance criteria. Fourthly, conduct a comprehensive risk assessment to pinpoint potential hazards linked to the RTS and assess whether a remote power disconnect would effectively reduce those hazards. In conclusion, the determination of whether to incorporate remote power disconnects on RTS ought to stem from a detailed risk assessment coupled with a careful consideration of the specific installation setting. Although UL 60950 doesn't explicitly call for remote power disconnects, the customer's apprehensions regarding safety merit serious attention and should be addressed through dialogue and compromise. The NEC, or National Electrical Code, doesn't specifically mandate remote disconnects for all remote tower systems or RTS installations. However, several articles within the NEC could influence the decision to include one, depending on the specific installation environment and the authority having jurisdiction, or AUJ. Article 440.14 addresses disconnecting means for air conditioning and refrigerating equipment, potentially relevant if the RTS unit contains such equipment. This section requires a readily accessible disconnecting means located within sight from the air conditioning or refrigeration equipment. A disconnecting means must be capable of being locked in the open position. Article 600.6 covers disconnecting means for signs and outline lighting. If the RTS incorporates any significant signage or lighting elements, this article might apply, mandating a disconnecting means within sight of the sign. Article 620.51 concerns disconnecting means for elevators, dumbwaiters, escalators, moving walks, lifts, and other equipment. Although unlikely, if the RTS involves any of these elements, these regulations would apply. Article 645.10 pertains to disconnecting means in information technology equipment rooms. If the RTS is installed within an information technology equipment room, this article could dictate the need for a disconnecting means. The general requirements for disconnecting means are outlined in Article 110.22, which necessitates that the disconnecting means be legibly marked to indicate its purpose, unless located and arranged so the purpose is evident. Article 225.31 requires that for outside branch circuits and feeders, the disconnecting means must be installed either inside or outside a building or structure served. This could be relevant for freestanding RTS units. Article 230.71 discusses the maximum number of disconnects, stating that each service must have no more than 6 disconnects for each service permitted by 230.2, or for each set of service entrance conductors permitted by 230.40 exception number 1, number 3, number 4, or number 5. It is important to also consider the local amendments, the AHA interpretation, the risk assessment, and the specific installation environment. Local jurisdictions often amend the NEC to address local conditions or concerns. These amendments can be more stringent than the NEC itself, potentially requiring remote disconnects in certain situations. The AHA has the final say on interpreting and enforcing the NEC. Their interpretation of the code, along with any local amendments, will determine whether a remote disconnect is required. A thorough risk assessment should identify potential hazards associated with the RTS installation. This assessment should consider factors such as the location of the unit, the likelihood of emergencies, and the potential consequences of power failure. Specific characteristics of the installation environment play a crucial role. Factors such as accessibility, exposure to weather, and proximity to other equipment can influence the need for a remote disconnect. In summary, while the NEC doesn't provide a blanket requirement for remote disconnects on RTS units, various articles could apply depending on the installation details. Consulting with a qualified electrician and the local AHJ is essential to ensure compliance with all applicable codes and regulations. NEC Table 310.15 details ampacities of insulated conductors. The ampacity of a conductor is the maximum current in amps that the conductor can carry continuously under the conditions of use without exceeding its temperature rating. NEC Table 310.16 specifically lists the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air, based on an ambient air temperature of 30 degrees Celsius. This table provides ampacity values for various conductor sizes, insulation types, and installation methods. The table includes adjustment factors for ambient temperatures other than 30 degrees Celsius, and for situations where multiple current-carrying conductors are bundled together. NEC Article 250.4 outlines general requirements for grounding and bonding. This article emphasizes the importance of creating a low impedance ground fault current path to facilitate the operation of overcurrent devices. It also addresses the grounding of electrical systems and equipment to minimize voltage to ground and prevent electrical shock hazards. Specific requirements within Article 250.4 include, firstly, grounding of electrical systems, which involves connecting the system neutral point to earth to stabilize voltage and limit overvoltages. Secondly, grounding of equipment, which requires grounding non-current carrying metal parts of electrical equipment to provide a path for fault current. Thirdly, bonding of electrical equipment, which involves connecting metal parts together to create a low impedance path for fault current. Fourthly, grounding electrode system, which defines the types of electrodes that can be used for grounding, such as metal underground water pipes, ground rings, and rod and pipe electrodes. Fifthly, grounding conductor connections, which specifies how grounding conductors should be connected to equipment and grounding electrodes. NEC Section 110.3 details requirements for examination, installation, and use of equipment. This section emphasizes the importance of using listed or labeled equipment and installing it according to the manufacturer's instructions. It also addresses the proper use of equipment and the need for adequate working space around electrical equipment. Key requirements within Section 110.3 include, firstly, listing and labeling, which requires that electrical equipment be listed or labeled by a recognized testing laboratory, such as UL, to ensure that it meets safety standards. Secondly, installation according to instructions, which mandates that electrical equipment be installed according to the manufacturer's instructions to ensure proper operation and safety. Thirdly, use of equipment, which prohibits using equipment in a manner that is not consistent with its listing or labeling. Fourthly, working space, which requires adequate working space around electrical equipment to allow for safe installation, maintenance, and operation. NEC Article 210.8 covers ground fault circuit interrupter, or GFCI, protection for personnel. This article requires GFCI protection for receptacles in specific locations, such as bathrooms, kitchens, garages, and outdoor areas, to reduce the risk of electrical shock. Key provisions within Article 210.8 include, firstly, dwelling units, which requires GFCI protection for receptacles in bathrooms, kitchens, garages, basements, and outdoor areas of dwelling units. Secondly, non-dwelling units, which requires GFCI protection for receptacles in bathrooms, kitchens, rooftops, and certain other areas of non-dwelling unit. Thirdly, specific equipment, which mandates GFCI protection for specific equipment, such as vending machines and portable generators. Fourthly, exemptions, which identify certain exemptions to the GFCI protection requirements, such as receptacles that are not readily accessible. Understanding these NEC sections and tables is crucial for ensuring the safety and compliance of electrical installations. Consulting with a qualified electrician and the local authority having jurisdiction is essential to ensure adherence to all applicable codes and regulations.